Hi everyone, my name is Yifang and my article is about the K and K band MIMO beamforming phased antenna array with multi-layer SICL fitting network. In this article, a reconfigurable waveguide antenna array designed for the MIMO beamforming system is demonstrated, which is fed by the multi-layer SICL fitting network. According to the design purpose, the reconfigurable waveguide transition and the waveguide linear polarized and circular polarized antenna array have high flexibility to meet different requirements in beamforming applications. The multi-layer SSAL fitting network could achieve wideband performance for both the MIMO beamforming transmission and the receiving system for K and K band respectively. The beamforming technologies are very popular nowadays, which could use the phased antenna array for its beaming enhancement to compensate for large propagation loss in high-frequency communications. For a massive MIMO beamforming system, the multi-layer fitting network is promising to achieve multiple inputs and outputs to provide flexible functions and multiple beams. The SSAL structure has advantages for the multi-layer fitting network on its low loss, compact structure, and wideband performance. The linear polarized antenna and the circular polarized antenna have their own advantages respectively for a beamforming system. The linear polarized antenna have better cross-polar isolation, lower cost, simple structure, and a lower profile. For the circular polarized antenna, it is widely used in satellite communications. It has its advantages in terms of the polarization mismatch and the multipath interference. All the waveguides share the same fitting network in the PCB, which are easily installed and connected by screws. The separated uplink and downlink need to achieve K and K band operation performance to reduce the influence and the interference. The reconfigurable waveguide transitions and the waveguide antenna arrays will provide a promising solution to achieve better wideband performance both for K and K band separated receiving and transmission system, instead of designing two whole systems with different dimensions. The reconfigurable linear polarized and circular polarized waveguide structure will also provide flexible functions and reduce the cost of the manufacture, installation, and maintenance. From the figure 1, it demonstrated the SSAL power divider, which used two side rows of metallic vias to reduce the interference of resonance in the network to provide a low loss and a wideband performance in high frequencies. The figure 2 shows the network of the beamforming system. We could say the reconfigurable waveguide transition and the waveguide antenna array could be connected by screws on top of the multi-layer PCB fitting network. Depends on the different requirements for different purposes. It is easy to install and replace the reconfigurable waveguide parts. The phase and gain control section chips will be installed at the bottom of the PCB. This is the preliminary stack-up design of the multi-layer PCB fitting network. It is challenging to manufacture a multi-layer PCB, so we need to consider more about the via and the layout to reduce the cost and the complexity of fabrications. In the figure 4, the structure of the linear polarized 2x2 waveguide antenna array is demonstrated, which use the step grid structure to improve the bandwidth, to reduce the size and help impedance matching. The home waveguide structure is also designed to achieve high gain. The figure 5 shows the simulated S11 of the linear polarized antenna array for K-band mode and K-band mode respectively. There are some copolar far-field patterns of the 2x2 linear polarized antenna array at 20 GHz and 30 GHz respectively. For the waveguide circular polarized antenna array, the figure 7 shows the structure of this 2x2 antenna circular polarized antenna array. The triangular shaped stable transform is adopted in this circular polarized waveguide antenna array to achieve a circular polarized operation by a combination of two modes with equal amplitudes and 90-degree phase shift. The theory is based on the odd and even mode analysis. The home waveguide structure is also used in this design to achieve high gain, and also the approximate hexagon structure is adopted to achieve wider bandwidth and lower profile due to the phase lag caused by its different guided wavelengths in this structure. The figure 9 shows the simulated simulated S11 of this circular polarized antenna array for K and K band respectively. There are some far-field patterns of the 2x2 circular polarized waveguide antenna for right-handed antenna and left-handed antenna at 20 GHz and 30 GHz respectively. We could calculate the antenna array beam angle based on this formula when we have 60 degrees phase shift for each antenna element, which are familiar with the main lobe direction from the simulated far-field patterns in figure 14. There are the simulated results of the axial ratio for 20 GHz mode and 30 GHz mode respectively. To get some preliminary experimental results, the single linear polarized waveguide antenna and the single circular polarized waveguide antenna are connected to the SSL to waveguide transitions to get some test measured results, which we could see the fabricated designs from the figure 15, and we could see the measured results for K band mode and K band mode of the two kinds of designs respectively in figure 16. There are the measured far-field patterns of these two kinds antenna designs, and we could see from the results both of the two designs work very well. In this article, our recent investigation into K and K-band MIMO beamforming phased antenna array with multi-layer feeding network has been presented. The reconfigurable linear polarized and circular polarized waveguide antenna could achieve wideband performance both on K and K-band, which could also provide flexible functions and are promising for the massive MIMO beamforming system in satellite communications, which are fed by the waveguide transitions and the SSAL multi-layer PCB feeding network. In the future, more measured results and analysis of the beamforming system with reconfigurable waveguide antenna transitions and the waveguide antenna array will be published. Thank you so much.